We are now solving question number 10 of this topic, work power energy for AS level for the M1. The question statement is a lorry of mass 15,000 kg climbs up a hill of length 500 meter at a constant speed. The hill is inclined at 2.5 degrees to the horizontal. The resistance to the lorry's motion is constant and equal to 800 Newton. Find the work done by the lorry's driving force. Second part, on the return of this lorry reaches the top of the hill with a speed of 20 meters per second and continues down the hill with a constant driving force of 2000 Newton. The resistance to the lorry's motion is again constant and is equal to 800 Newton. Find the speed of the lorry when it is going to reach at the bottom of the hill there. So this is the data given to us that mass is 15,000 kg, angle is 2.5 degrees with the horizontal, the speed is constant. It means there is no change in the kinetic energy of the system. The resistance to the motion is 800 Newton, and you are going to calculate the driving force of that lorry is there. So we can know from this example that work done by the driving force minus work done by the frictional force is equal to change in kinetic energy of the system plus the gain in potential energy of the system there. But since this force is equal to zero because initial is the same as the final speed, our speed is constant. So this will become work done by driving force minus work done by frictional force is equal to mgh. So work done by driving force will be equal to work done by friction plus mgh. In this equation, we know that this distance by this lorry is 500 meter at an angle of 2.5 degrees, and this is the height of that. So we can use this formula there, that height is equal to 500 into sine of 2.5 with the help of the trigonometric ratios there. So the driving force will become equal to the mass of that resistive force is there equal to 800 into the distance it has moved from bottom to the top is 500 plus mass of that particle is 15,000, g is 10, and the height we have gained equal to 500 into sine of 2.5. And this calculation, after doing from the calculator, it is going to be equivalent to 3671 454 02 joules. It is work done by the driving force. So work done by the driving force is basically equal to 3671454.02 joules of this particle there. And the second part is that Now this lorry is coming downward. So on the return of this journey, so our total distance is still 500 meter, but they have given us the driving force equal to 2000 Newton, and the resistive force is the same as 800 Newton. Angle is same, mass is same, and you are going to calculate the speed where it's going to reach at the bottom of that hill there. So we know again one thing, that work done by the driving force minus work done by the frictional force is equal to change in kinetic energy of the system, because it is now coming downward. So potential energy will be lost. So we are going to use it as minus mgh there. So from this equation, half m v square minus u square is equal to mgh plus work done by the driving force. Driving force is 2000 into the distance is still 500 plus minus work done by the frictional force, that is equal to resistive force is 800 into distance there is 500. So we can use this equation into this. So half mass of that particle is 15,000 into v square, we don't know, u square is 20 square, that thing is equal to mgh. Mass of that particle is 15,000, g is there 10, height there is equal to 500 sine 2.5 degrees plus 2000 into 500 minus 800 into 500. So finally, v square after doing this calculation is equal to so it is 916.2, and this will be equal to 30.3 meters per second is the speed of the lorry when it is going to reach at the bottom after covering a distance of 500 meter at an angle of 2.5 degrees. So this was the complete question for this question number 10 of this